So what I would like to show now very briefly is some kind of lower technology than what we have seen before. But also I would try to convince you that having laboratories involving high technology and science and fundamental research can be useful also for the traditional sectors of our industry, which we traditionally consider low technology, but it is not low at all, as we all know. So I will just briefly say a few words about our center and why surfaces and interfaces are important. Then I will give some example about industrial sectors with whom we have been working in the past few years and conclude with a perspective. So one of the organizers of this conference is the NIS Center of Excellence, which is a center of excellence of the Italian Ministry of Education since 2003, and it is also an inter-department center of the University of Torino. It is based on an effort to bring together people working in different areas, especially physics, chemistry, and biology. And what they have in common, these people, is a long-standing experience in surfaces, in the study of surfaces for different purposes, like catalysis or metallurgy or interaction with the human body and many other things. This center is supporting some labs which exist since a long time, and this is a good thing, but also it is also offering new labs common to all these researchers from different areas. And also we organize conferences, and we try to be a contact point for the whole regional system of research, which has many actors, but too often they work alone and they do not communicate with each other. Why surfaces? Well, because the surface of a material is the way the material interacts with the rest of the world. So it is very important from many, many points of view, because it determines, for example, the appearance of, I have to find, for laser, where is it? Oh, it is very weak. It determines the appearance, it determines the porosity of the material, but also how this material can become dangerous or can release substances. It controls one very important mechanical property like adhesion, but it can possess chemical activity and be a catalyst for reaction we want or for reactions we do not want. Therefore, we are convinced that the study of surfaces has a role in nanotechnology. And indeed, it's always been the case, and the science of surfaces and especially of porous materials has been part of nanotechnology since the beginning. The center is an integrated place where people are doing research at different levels, and I would like to convince you that it is important to do research at different levels in the same place. That is, some of us are doing fundamental research, for example, on molecular interaction, on the electronic structures of molecules, but also on spectroscopic techniques to detect the properties of molecules and surfaces. These may not have immediate applications, but are very important in order to be able to do applied research on frontier topics, which usually means making projects on a long-term scale. I cite a few examples. All of these examples are not theoretical, are real projects which are going on in our labs. For example, the interaction of biological molecules with surfaces, which can be used to make, for example, diagnostic kits, or photovoltaic cells of new kinds, like those we have seen in the previous talks, or the development of rapidly solidified alloys, so the so-called metallic glasses. All of these do not have immediate application. There is still a lot to do because these produce innovation which goes to the market, but it is still applied research. And then there is a third level of research, which is doing short-term research for the industry which is already working, selling products, and working especially in this territory. And this means the automotive industry especially, but also all other consumer goods like plastic goods of low technology or high technology like LCD monitors. And also all that part of the mechanical manufacturing industry doing things for our houses, like water taps or cooking pans. And another very important sector is that of textiles, which are everywhere around us. And finally, there is still a lower level of activity that is working, providing knowledge to people who has no time to study. I mean, this is a very important thing for a university. So we very often do bibliography study. We study patents for people who do not have time or culture to understand them. We do failure analysis on components, especially where chemistry is mixed with mechanical properties. And we do a lot of microscopy, for example. And you need a good microscopes even to study simple materials. And you can get really a good insight into complex problems. So these two lower things, so working on present technology and doing consultancy on technology would not be possible without these other projects on the top, because the instrumentation we use to do this is the same we use to do this, and we would not be able to pay this instrumentation without the project we do on the long term with the public sector. This is why being a big center is important. So why, I come to the third example, why is important, how can in the traditional industrial sector like mechanical or chemical sector benefit from our machines, which we use also for nanotechnology? Well, very often we can address the problem of the quality of the products, but also another very important demand from the industry is to address the new applications of old material. So a company is producing one material, and the market for that material is vanishing or decreasing, where very often it is other markets are possible, but these have different requirements from the previous market, and we can address these requirements. Also, the opposite is real. So sometimes there are some old applications, things one have been doing with metal for a certain alloy for many years, but we can help understand if it can be done with new materials. And also related to quality is the understanding of what happens during manufacturing of materials to the atomic scale and not only to the macroscopic scale. This helps reducing defects and finding new way to improve the processes. Also, another field where we have been working is the transfer of applicability of technologies from different sectors. That is, for example, from high-tech industries to more low-tech industries. And finally, safety and health of materials. So the way materials we handle interact with the human body and with the environment is also a point we can address. I give a few examples. If I will not mention all, but just a few important ones. Cellulose acetate is one of the most, I would say, ancient plastic polymeric materials which are on the market. The traditional markets for this were photographic films, which do not exist anymore, or almost do not exist, and paper filters, which is also a decreasing market. But at the same time, now cellulose acetate is needed for LCD screens because it has exactly the right optical properties for some protective layers which are on all of the LCD screens in our offices. And at the same time, it is derived from natural feedstock. So it is an engineered natural polymer, and it is interesting for our future for that reason. Obviously, the old plants which produced produce acetate for paper filters are not suited to produce the quality of acetate which is needed for high-tech applications. So we have been working since 2 years in understanding the defects in particular the optical defects in the acetate film. And so we have discovered, for example, that there are many stages. These are the bright dots appearing on an LCD screen when there is a defect which has a different refraction index than the rest of the material. And we have found that these bright spots are either pieces of cellulose which are not acetylated due to different reaction speeds, or additives used in the process which have precipitated in the scale of nanometers, like in these 2 other cases. This has led us to study the anatomy of natural cellulose, which in the end will end up in our monitor screen. So the anatomy determines the shape of the cellulose, so how crystalline is. This is a crystallinity profile obtained by X-ray diffraction of several cellulose samples. So the anatomy of the cellulose determines how homogeneous the reaction takes place, and this is very important to have a homogeneous film. Many other examples come from metallurgy, which, as we all know, is the key industrial sector in this region. I will cite only a few. Traditional brass is used for taps, for water taps, but this is no longer possible to use because traditional brasses contain lead, this bright material, bright droplet in the alloy. Lead is not allowed anymore in many objects which come in contact with food, and in many countries it's not possible anymore to sell taps done with lead-containing brass. So an interesting project we have is that of understanding why lead is needed by this industry, and I mean we know from the industry that it's needed for machinability of brass, but also to find new kind of precipitates which are health friendly to maintain the same machinability of the alloy and avoiding the use of lead. Another example related also to the local industry is the reinforcement of die castings using coatings. And this example, this is a nanometric powder which is deposited on steel by means of a thermal spray method. Then we do a lot of failure analysis. And failure analysis nowadays is not what it was 10 or 15 years ago, that is doing simply optical microscopy and fracture analysis. I mean, we really need good microscopes, and we need a lot of chemical analysis, especially to understand failure analysis when we have mechanical chemical systems. So to get corrosion and mechanical stress together. And then there are many other sectors, but I mean, it is easy to understand that metallurgy is very important. I will just mention coatings without going into the details, because there has been an extensive regional project on this, which is this NanoMat project. You can have all the details and the examples concerning this project on this website. Some areas where we have been working are, for example, CVD coatings, like diamond coatings for mechanical applications, but also for biomedical applications, and also carbon coatings to do all that you can do with carbons. Another area is that of the control of thermal properties of materials, especially of construction materials. Construction, I mean, the market for insulating materials and for reflecting materials is growing and is very important. So 2 projects we have are related to making insulating paints by mixing highly insulating nanopowders with traditional paints and coatings, or the problem of tailoring the absorption of plastic components for architecture by using molecules tailored to have a specific absorption or reflection properties. another area where we do a lot of work is that of galvanic coatings and also anodization, where especially defects problems are important. And finally, a few words about textiles. The world of textile is intrinsically, I would say, related to nanotechnology. Here are some examples. One is related to carbon fibers. You know, carbon epoxy composites are materials which have a growing importance, especially in the aerospace industry, but also in some niche markets like sport goods and the automotive. And carbon epoxy composites, they do not break because we break the carbon, but they break because of poor adhesion between carbon and the epoxy. So we have, some colleagues of us have developed a way to grow some very tiny carbon fibers, so the kind of what we call nanotubes, on the external surface of larger fibers. And these larger fibers can be carbon or aramidic fibers. And this will improve the wettability of the carbon and the adhesion between the carbon and the epoxy. A completely different application, also using nanocharged polymers, is this. So the development of a gas-proof, a helium-proof coated textile, which had to be very robust, but also to contain helium for this kind of vehicle, which is a metaplane, that is a flying vehicle which is partially filled with helium, and so it can, because of the thrust by helium, it can fly at very low speed. So for this, we have developed together with some local producer a very strong fabric using commercial fibers, but also we have coated it with a polyurethane film, which contains ordered clay nanoparticles to decrease the permeability to gases. And we have improved significantly the impermeability. Another field related to textiles is the area of self-cleaning materials, where this is a project done for Città Studi in Biella, where a cotton fiber has been coated with a very thin titanium dioxide layer to make it self-cleaning when illuminated. So these were just a few examples, just to show which opportunities researchers have to work for the so-called low technology industry, which is not so low, as I hope I have shown. So many companies do not do their research in-house, and they need our help to do research. And this is a great opportunity for public labs. But also, we experience that this is a risk for the companies because very often the loss of technical capacity and scientific capacity within a company can become critical. This is our experience. Also, I hope I've convinced that advanced lab can provide services also to the traditional sectors. And also, one thing which I never stop to stress is that after these few years of experience in the traditional industry, we really feel the need for an appreciation of fundamental research by the industry. And in particular, what we very often, the problems which are coming from the industry have only one solution: to have a graduate in science in the staff. Too many small companies do not have graduate in science in their staff, which would be enough to solve many of the problems which we as a university are asked to solve. And finally, one thing which I don't know if it is good or bad is that our experience in managing these projects, which means making them work and be sustainable from the economic point of view, is that we need support from the public sector. Because in general, especially small companies are not available to pay the real cost for the machines we use and for the research we do. And this is a problem for us, but it is also a matter of appreciation of the value of scientific culture in general. And I thank you for your attention, and that's it.
The session is open for questions. We are a little bit late, but I think that this talk should have given some hint related to high tech and low tech. Yes?
You have shown the carbon fiber coated by carbon nanotubes, if I understand right. Did you measure any mechanical property of that composite material?
Well, not yet. This is a patent which has been developed by a company, a local company, and the samples we have been able to make until now are very small, and they are not large enough to make mechanical testing. But we are in the process of making a larger furnace to grow the nanotube. These are grown by CVD technique from the gas phase, so it is a little bit critical to grow them in the right place and with the right in the right form without damaging the fiber. But we are working at it.
Any other question from the audience? So
I have just a question. So you've shown self-cleaning coatings for textile applications. Yeah. Do you work also on self-cleaning coatings for hard materials and surfaces? Such as glass surfaces, something like that.
The subject of self-cleaning or even air-cleaning materials based on photocatalysts is very popular in these days, and there are many groups, even in our center, working at it. For example, I'm involved in one project for concrete-based materials, where we have tested self-cleaning cements and tested also their ability to degrade NOx pollutants. Others are working on the same materials, for example, in solar cells, so titanium dioxide films, or also there is another talk in another session, probably at the same time of this, about the use of photocatalysts to clean the air in museums where some kind of pollutants can damage the work of art. So it is definitely a very active field. And also very close to the real application. There are already some applications.
If there are no more questions, we thanks again the speaker.
I forgot to say one thing. We have a catalog of our research in press. It is the printed version is not yet available here at the NANOFORUM, but you can request it at this address. And it has plenty of examples and the bibliography and the patents and everything. Thank you.